Okay, so I want to do a quick little lesson on even and odd functions, which is a topic that comes up in chapter 2. We come back to it a little bit and it becomes important in calculus. The idea is that a function can be even or it can be odd. It doesn't have to be one or the other. But when a function is even, an example of a function that's even could be this. This is what I'm trying to draw is y is equal to x squared. And the reason it's even is because if you picture folding it down over the y-axis, it's symmetric. Okay, so a function that's even is symmetric about the y-axis. A function that's odd, a common example that we've talked about a little bit in this class, is the function y is equal to x cubed. Okay, so if you fold this function twice over the x-axis and the y-axis, you're going to get symmetry. And another way of thinking about this symmetry is if you fold it over the line y is equal to x. Okay, so a function that's odd is symmetric about the origin. A function that's even is symmetric about the y-axis. If I just have a function that's even and I draw something like that, the symmetric function, an artist could do this better than me, is going to look like that. If I try that same thing with an odd function, I've done it and failed so many times I know that I can't figure it out. But if I had something like this, then it's going to look the same but flipped in quadrant 3. Okay, so the rule, if you think about what's the rule for even and odd functions, if I have an even function, and let's say I'm going to think in terms of a table, and let's say I put a couple numbers into the even function, like, I don't know, maybe 1, 2, and 3, and I get a couple different numbers out, like, I don't know, 4 and 7 and 8. What makes it an even function is that when I put -1 in there, I'm going to get the same thing out. I'm going to get 4. When I put -2 in there, I'm going to get 7 out. When I put -3 in there, I'm going to get 8 out. And if you look at why that's true or how that corresponds to the picture, if you think of drawing a line at any one point, this point might be 2, this would be -2, and they both have the same x value. Let's say in this case it's 4. Okay, so that's what makes it look even. If I think odd, and I do the same table thing, and I put 1, 2, and 3 in there, and then let's say in this case I'll stick with the same numbers, 4, 7, and 8. If it's odd, when I put -1 in there, I'm not going to get 4, I'm going to get -4. And when I put -2 in there, I'm not going to get 7, I'm going to get -7. And I'm not going to get 8, I'm going to get -8 when I put in -3. And you can see that in this one too. Like if I think, let's say this is 3, and this is, well, in this case it would be 27. The graph is not drawn to scale. But at -3, I get -27. Okay. Writing the rule for this can be tricky, but essentially the rule for an even function is when I reverse the argument, when I take f of -x, I get the same outcome. So f of -x is equal to f of x. The rule for an odd function, and this is for all x, by the way, when I take the opposite of the argument inside, I get the opposite of the whole function itself. F of -x is equal to negative f of x. And so frequently you're asked to show if a function is even or odd. So let's say show if the function is even or odd. and I'm thinking f of x is equal to the absolute value of x. And you could kind of do your table. And let's say I put in 1, 2, and 3. I get -1. No, sorry. I get 1, 2, and 3 out. And if I put -1, -2, and -3 in, I get 1, 2, and 3 out. So you could be looking at this and thinking, I just proved that that function is even. Because when I reverse the argument, I get the same f of x out. However, you haven't proven that function is yet, because I said that this has to be true for all x. So unless you want to go through and plug in every number between 1 and infinity, or between negative infinity and infinity technically, you got to find another way. So the way to do this that's more abstract and proves that it's true for every single x is by evaluating what is f of negative x. So f of negative x is going to be absolute value of negative x, which the absolute value of negative x is just the same thing as absolute value of x. And so now I can say f of negative x is equal to f of x, therefore even. Let's try another one. Let's say f of x is equal to x cubed plus 4x. F of negative x is going to be negative x cubed plus 4 times negative x. Well, if I simplify that a little bit, I'm going to get negative x cubed minus 4x. And that is clearly not the same as f of x. So at this point, I can rule out the fact that it might be even. However, to determine if it's odd or not, I have to evaluate what's negative f of x, okay? And that's different. F of negative x is when I put a negative x inside everywhere the x goes in the original function. Negative f of x is when I just take the original function and put a negative sign on the outside of it. Okay, and you distribute, when you have terms that are separated by addition or subtraction, you distribute that minus sign into them. So this would be negative x cubed minus 4x. And it looks like this and this are the same expression. So this is odd because f of negative x is equal to negative f of x. Let's say I have f of x is equal to x cubed plus 1. I look at it and I might think it's got an odd exponent, so it's probably not going to be an even function. But let's just evaluate what is f of negative x. So that's going to be negative x cubed plus 1. And what is negative f of x going to be? Well, that's going to be negative x cubed plus 1, which is negative x cubed minus 1. Are these the same? These are not the same. So this is not odd. This is not even. This is something we call neither. And so those are the examples of all three potential cases that you could get. Doing the algebra can get trickier. So I picked one out that's maybe a little bit trickier. So let's say f of x is equal to x times the square root of x squared minus 1. I'm going to plug in negative x. And I'm going to get negative x times negative x squared minus 1. Well, on the outside term, I can just move the negative sign to the outside. And then on the inside, negative x squared is just going to be x squared minus 1. And now if I do negative f of x, so this is going to be negative x times the square root of x squared minus 1. Now, since these two things are factors, x and the square root of x squared minus 1, they're separated by multiplication, not addition or subtraction. I'm not distributing that minus sign into every single term. So this is the same thing as saying negative x times the square root of x squared minus 1. So in this case, f of negative x is equal to negative f of x, and therefore the function is odd.